Hello everyone, I am Saranya, Assistant Professor in the Department of Graphics and Creative Design of Dr. S.N.S. Rajakshmi College of Arts and Science. In this video, we are going to see about the computer networks and data communication in the TCP/IP protocol architecture. The TCP/IP, the full form is Transmission Control Protocol, Internet Protocol. It is a fundamental communication protocol that establishes the rules and procedure for how data travels across the network. Think of its universal language that allows the various devices, regardless of their manufacturer or operating system. The TCP/IP operates within a layer model, with each layer handling specific tasks, which we'll explore in detail in upcoming slides. The next is the need of protocol. Just like human need a common language to understand each other, devices also require protocol to communicate efficiently. Protocol establishes a set of rules that govern how the data is formatted, how devices identify themselves on the network, and how the errors are detected and corrected. These ensure that data sent from one device can be accurately interpreted and received by the another device, regardless of its origin. A network type, the protocol plays a vital role in interoperability, the availability of different systems to work together, which is essential for the network of the internet. The introduction of TCP/IP model. The TCP/IP model serves the blueprint of the network communication. It is a layered architecture, often displayed as a stack, with each layer handling a specific set of tasks. This modular approach allows for independent development and modification of individual layer without affecting the overall functionality of model. We will be exploring each layer in a detailed. Application layer. The first layer, the application layer, is at the topmost layer in the TCP/IP model, and it also interact directly with the user application such as web browser, email clients, and file transfer programs. It offers a set of well-defined protocol that this application can leverage to access network resources. The common examples of application protocol include HTTP, SMTP, POP3, FTP. HTTP is nothing but text transfer protocol, which is used for web browsing. SMTP is simple mail transfer protocol. The next is POP3, post office protocol. It is mostly used for the email. Simple mail transfer is also used for simple email. FTP is for file transfer protocol. It is used for transferring the file operation. Transport layer. The transport layer acts as a intermediary between the application layer and the network layer. It is responsible for taking data from the application layer, splitting it into the smaller packets if necessary. It also it has the ensuring its delivery to the designed application and receiving the device. This layer offers two primary protocols. First one is TCP and UDP. TCP is Transmission Control Protocol. UDP is User Datagram Protocol. TCP establishes a connection with the receiving device in order to deliver of data packets. It also checks for an error, implements the congestion control to avoid the overwhelming of the network. The UDP is in the another hand, it prioritizes the speed over reliability. It doesn't establish the connection, doesn't coordinate delivery, and doesn't perform the error checking. This made UDP suitable for real-time application like video streaming or online games. Next is internet layer. The internet layer is the workhorse layer of the TCP and IP model. It responsibility for routing data packets across the interconnected networks. This primary protocol at this layer is the Internet protocol. IP assigns a unique logic address to the device, enabling them to identify and locate on the Internet. It also received from the transport layer into the packets, including header information like source and destination IP address. The Internet layer also plays a vital role in determining the most efficient route for these packets to travel across the network, ensuring they reach their intent destination. Network access layer. A network access layer is also known as the physical layer. It interacts directly with the physical layer media network. This layer is responsible for actual transmission of data packets over the network using the physical components like cable, network adapters, and network interface cards. This specific protocols used at this layer depends upon the type of physical media employed. For example, wired network often use the Ethernet protocol. Wireless use the Wi-Fi protocol. The network access layer ensures the reliable transmission of data bits across the physical network infrastructure. Benefits of TCP/IP: interoperability, modularity, scalability, flexibility. It contains the some of the widespread and success points. First one is interoperability. TCP and IP ensure that the device from different manufacturers and running various operating systems can communicate efficiently. This can be instrumental in the growth and diversity of the Internet. Modularity. The layered architecture allows for independent development and modification of specific layer without affecting the overall functionality of the model. Scalability. The TCP/IP model can accommodate vast and ever-growing Internet infrastructure. It can handle the ever-increasing number of device and data traffic on the Internet efficient. Flexibility. TCP/IP can adapt to new technologies and protocol as needed. This flexibility allows the Internet to constantly evolve and integrate new advancement. The future of TCP/IP. The TCP/IP model is not as static. It constantly evolves to address new challenges and opportunities. IPv6. The current version IPv4 is nearing for its address space. The IPv6 offers a significant larger address pool to accommodate the ever-growing number of devices on the Internet. Security consideration. The digital landscape is constantly evolving and new security threats are emerge. The future of TCP/IP will likely involve incorporating enhanced security measure at the different. The next is security consideration. The digital landscape is constantly evolving and new security threats are emerging. The future of TCP/IP will likely involve incorporating enhanced security measure at the different layer of the needed. Integration with the new technology. The rise of Internet IoT and the new network architecture presents both challenges and opportunities. The TCP/IP model will need to integrate a similar with these evolving technologies. Thank you.